Today we're going to look at LeetCode question number 235, lowest common ancestor of a binary search tree. So given a binary search tree, find the lowest common ancestor node of two given nodes in the BST. According to the definition of the lowest common ancestor, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P as Q as descendants, where we allow a node to be a descendant of itself. Okay, so what does that mean? So for example, P is 2, Q is 8, the lowest common ancestor, okay, the lowest ancestor for these two have in common is 6. And similarly for like 0 and 5, the lowest common ancestor is 2, okay, obviously not 4, because 4 is not an ancestor of 0, so obviously it has to be 2. And also a node can be a descendant of itself, so if we have P is 2 and Q is 0, then the lowest common ancestor is 2. Okay, so how are we gonna go about this? So what we're gonna do is basically we kind of have to check is the node either P or Q? If it is, then we found the lowest common ancestor basically. But if it's not, like let's say a lowest common ancestor is like 7 and 9, you know, then we have to kind of search. So we have 6 here. Is 6 an ancestor of 7 and 9? Well, yes, but it's not the lowest. How do we know it's the lowest? Well, an easy way to know is, you know, either the node is equal P or Q, okay? But another way is check the node here, and if P is on the left side, check the node, and if P is on the left side and Q is on the right side, or vice versa, Q is on the right side, P is on the left side, then this node is an ancestor of the lowest common ancestor, of P and Q. Okay, let's analyze this for a second. Let's analyze this property, where if P and Q are a left and right side of a node, then that node is the lowest common ancestor. Okay, so let's say we have P and Q is 0 and 9. Okay, lowest common ancestor is 6, where 0 is on the left and 9 is on the right. Okay, what if we look at 2? Well, 2 is not an ancestor of 9, so we can't. So that's not a valid solution. What if we look at 8? 8 is not an ancestor of 0, so that's not a valid solution. Therefore, it has to only be 6. What if we're looking at 7 and 9 here? Well, yes, 6 is an ancestor of 7 and 9, but it's not the lowest. We can definitely do better. And if P and Q are on one side of a node, like either the left side or the right side, that means we can do better. We can find an even lower ancestor. So in this case, the lowest common ancestor is 8. Okay. Similarly, for like 0 and 5, 6 is an ancestor, yes, but it's not the lowest. Okay. 0 and 5 are exclusively on the left side of 6. So let's go lower. 2. 0 is on the left side, 5 is on the right side. Great. That's the lowest common ancestor. So 0 can't be a solution because 5 is not an ancestor of it, and 4 is not a solution because 0 is not an ancestor of 4, and yeah, that's how it goes. Okay, so that's basically how we're gonna go through this algorithm. It's breadth first search. It's gonna take linear time of n. So now what we're gonna do to code this up is helper, and this is my recursive helper, and it's taking root. So my base case is if root is none, obviously return none. And if root is P or root is Q, that means we found a node can be a descendant of itself. So we found the node itself. Then we're gonna return root. Else, what we're gonna do is have the left recursively call root.left and right is equal to helper root.right. Okay. Now we want to check. So if left is not none and right not none, return root. So what does this mean? So let's say we were here, okay, and we were looking for, I don't know, 5 and 1. Okay, so we do the recursive call for left. Okay, left. Oh, it turns out we found 5. Okay, so return that, and left is now 5. It's not none, meaning. Okay, on the left subtree we found either P or Q, and for right we again searched to right, and we found it was either P or Q. It was Q in this case of 1. Okay, and since left is not none and right is not none, we return root. Okay. What if this isn't the case? So if left is not equals none, turn left. Okay, this basically means, so if left is not none, okay, then on the left subtree we have our values, so we should return left here. Okay, we found one of our values. Else return right. So if left is none, okay, that means on this particular node in the left subtree here, we don't find P or Q, so obviously it has to be on the right side. Okay, and that's basically how it goes. So what we're going to do is turn helper root. Okay, so now we're going to run. Okay, looks good. I'll submit. Okay, great. Thanks for watching.